Assalamualaikum, I am Nazmus Sakib and this is my presentation on register allocation, a complex engineering problem. First of all, we will have a look at the key terminologies and then get into the main content. First, we have registers, the ultra fast cache space beside the core. We have spelling when two variables have the same register but one of them have to move out, so they get into the RAM. We have like terms like life length or lifetime, liveness analysis. We'll talk about them later. We have interference when two variables share the same register, and eviction when on selecting which register to selecting which variable to kick out when they share the same register. Splitting, we'll talk about later. Priority queues, max heap that always serves the most important variable first. The hardware bottleneck. So CPUs only have a number of registers 16 or 32. Microarchitecture may provide 96 or more, but the real code only uses architectural registers provided by the ISA. Thus, the ISA has to send the values to temporary memory or stack when at the time of a program there are more number of variables than there are registers. Let's look at the NP complete problem graph by coloring. It's very important and for understanding register allocation. Think of the nodes as variables, ages as the variables used at the node ages as the variable used at the same time with other variables. Colors as the same number of registers represented by k. We need to find a combination where no adjacent nodes have the same color. So if it was a complete graph where all nodes are connected to all other nodes and a new node is introduced here, then we won't have a new color for the new node. So we'll have to remove one node from that graph and insert the new node there. So this is the problem the register allocation faces. So what kind of problem is register allocation? So it's an NP problem. We can verify it by saying that the neighbor of a node is not the same color. It's an NP hard problem, as Chaitin proved it by reducing the graphical coloring problem to register allocation problem. So NP hard and NP problem gives us a NP complete problem. So what is the LLVM solution for this? So LLVM has a greedy solution named Ray-Gallo greedy. It uses a max heap and the variables lifetimes. The longer the variable lifetimes is, the higher the priority, and it all uses strategies like eviction, splitting, spilling inside to give us the full algorithm. So we have been talking about liveness for a while now, and liveness, lifetime. So what does it mean to be live? So a value is live from its definition until the last use that still needs it. Liveness, it's not always continuous. Maybe it will be used for 2 or 3 instructions at the beginning, then it won't be used for a long time, then it will be used again for 6 or 7 instructions. That's liveness. It may have hole between the amount of time that it won't be used. So the longer the liveness of something, the more it will overlap with other variables lifetime. Suppose we have a tiny register file containing 2 registers. We have variable A and variable B, so we can give each of them the registers, so they both live here. And what if another variable comes, but since we have 2 variables, we can give C the register right now. So what is our plan? So we have a strategy. We can split the C and we can split C and create its new lifetime, maybe make a whole and see if the new created lifetime can be placed somewhere here that it doesn't collide with A or B's lifetime. But if it still collides, we need to evict one of them. So yes, so when splitting isn't enough, so we must split it. So split into the memory. So here's the total overview. So we first analyze, run DFS to compute the liveness, push everything to max if. Then we enter the process loop, pop the highest priority, assign a free register. If one does not exist, maybe go through evict, split or spill. And lastly, if it spills, we insert load stores, lifetime change, and rebuild the heap and run again. So what are the algorithm components we have? First the most important part, we have the greedy algorithm from Regalo greedy. We have DFS for liveness analysis, sorting for priority max queue, and of course the complexity classes. Why this qualifies as a complex engineering problem? It needs a very in-depth knowledge is for of compilers, data flow, graph theory, and pickup blenders and heap structures. P2 for conflicting requirements. Aggressive splitting speeds up runtime but slows down compile time. It doesn't have an obvious solution as it's an incomplete problem. It's infrequently countered. People doesn't usually build this stuff. It's outside standard. No external code dictates spill cost ratios. Pure engineering judgment. In interdependence interacts with instruction scheduling, SSA deconstruction, changes ripple both ways. So lastly, this is a very interesting problem, and the solutions provided by LLVMs, reg alloc greedy is very interesting. It's solving a NP complete problem, and as we use the compiler, we it's really fast. That is all. Thank you. Assalamu alaikum.